y equal to mx plus c. Now one point and slope given. Now if we have been given one point through which the line passes and a slope has been given about that particular line, then the equation of line becomes equal to y minus y1 equal to m times x minus x1. Here m is the slope and x1 comma y1 is the point through which the line passes. Once again, if we have been given one point x1 comma y1 through which the line passes and it is given that it makes an angle of theta, or the slope of this line has been given, then we can write the equation as y minus y1 equal to m times x minus x1. Now equation of line passing through 2 points. Let P and Q be the 2 points which are given by the coordinates x1 y1 and x2 y2, and it has been given that the line passes through these 2 points. Then in this case we have seen that the slope is equal to y2 minus y1 by x2 minus x1. So m would be equal to y2 minus y1 by x2 minus x1. And if I take this point, it passes through this point and I know the slope. So I can write the equation as y minus y1 equal to y2 minus y1 divided by x2 minus x1 into x minus x1. Here y2 minus y1 divided by x2 minus x1 is the slope of this line. Once again, if I have been given 2 points x1 y1 and x2 y2 through which the line passes, then the equation of such line is given by y minus y1 equal to y2 minus y1 divided by x2 minus x1 into x minus x1. Here y2 minus y1 by x2 minus x1 is the slope of this particular line. The next is intercept form of a line. Now we are going to find the equation of line making x-intercept equal to a and y-intercept equal to b. That is, this is the coordinate axis. Now if this is the line and it makes an intercept of a units on the x-axis, and similarly it makes an intercept of b units on the y-axis, then in this case the equation of line becomes x by a plus y by b is equal to 1. Once again, if this line makes an intercept of a units on the x-axis and makes an intercept of b units on the y-axis, then the equation of such line is given by x by a plus y by b is equal to 1. Note here, the coordinates of a point where it meets the x-axis become a comma 0, and the coordinates of point b where it meets the y-axis becomes equal to 0 comma b. So students, once again it's time to solve an IIT problem. It appeared in 1985 and it says that one of the diameter of the circle circumscribing the rectangle ABCD is 4y equal to x plus 7. If A and B are the points minus 3, 4 and 5, 4 respectively, then find the area of rectangle. Now in this problem it has been given that ABCD is a rectangle and we have been given the coordinates of point A and point B. Now one more condition that is given to us is the diameter of the circle circumscribing this rectangle, and its equation is 4y equal to x plus 7. Finally we have to find the area of the rectangle ABCD. Now how to do it? It's actually a very simple problem. Let's just go through the solution of it. Now this is the rectangle ABCD and this is the circle that is circumscribing this rectangle. Now the coordinates of point A are minus 3, 4 and coordinates of B are 5, 4. Now we see that the slope of AB is equal to 4 minus 4 divided by 5 plus 3, and that is equal to 0. So the slope of this line is equal to 0. Now if I draw a perpendicular from O to P, then it actually bisects this segment AB. So P is the midpoint of AB. Therefore we can easily find its coordinates. So P becomes 5 minus 3 by 2, 4 plus 4 divided by 2, or the coordinates of P are 1, 4. Now the slope of this line is equal to 0. Slope of this line is equal to 90 degree. That is, this line is parallel to the y-axis. So the equation of this line is of the form x equal to b, or x is equal to 1 is the equation of OP. Now we know the equation of OP, and we have been given the equation of another diameter is 4y equal to x plus 7. So these two lines would intersect at the center of this circle, or we can say that at the center of this rectangle. So the point of their intersection is 1, 2. we solve this equation and this equation, so we get the center as 1, 2. Now O is also the midpoint of BD. BD is the diagonal of rectangle, or you can say it is the diameter of the circle. So O divides BD. Now we know the coordinates of O, we know the coordinates of B, and we know that O is the midpoint of BD. So we can easily find the coordinates of D. Let the coordinates of D be A, B. Then A plus 5 by 2 is equal to 1, or A equal to minus 3. And B plus 4 by 2 is equal to 2, or B equal to 0. Thus the coordinates of D become minus 3, 0. Now the length of AD is equal to this distance, and which is nothing but equal to 4. The length of AB is this distance, which is equal to 8. Hence I can say that the area of this rectangle ABCD is equal to 4 into 8, which is 32. So the area of rectangle ABCD is 32 units. Once again, what we have done in this problem is, we have found the midpoint of AB, that is P, and we have found the equation of OP. Now OP and one more diameter intersect at the center, so we have found the coordinates of point O. Now we know the coordinates of point O, we know the coordinates of point B, and we also know that O is the midpoint of BD. So we found the coordinates of point D. Once the coordinates of D are found, then length of AD and length of AB is calculated, and AD into AB is equal to the area of rectangle ABCD, which is nothing but equal to 32 units. Now let's look at another form of a line, that is the normal form of a line. Now this is a line, it intersects the coordinate axis at A and B, and it has been given that a perpendicular is being dropped from O to this particular line, and we have been given the length of this line as equal to P, and it has been also given that it makes an angle of theta with the positive direction of x-axis. This perpendicular makes an angle of theta with the positive direction of x-axis. The x-intercept would be equal to P sec theta, and the y-intercept would be equal to P cosec theta. Now we know the x-intercept and the y-intercept, so we can write it as x by P sec theta plus y by P cosec theta equal to 1. This is the intercept form of a line. But 1 by sec theta is nothing but equal to cos theta, and 1 by cosec theta is equal to sin theta. So the equation reduces to x cos theta plus y sin theta equal to P. Once again, in this normal form of line, if we have a line and a perpendicular of length P is dropped from the origin to this line, and this perpendicular makes an angle of theta with the positive direction of x-axis, then the equation of this line is x cos theta plus y sin theta equal to P. Now how to find the equation of a line parallel to a given line? If we have a line AX plus BY plus C equal to 0, and if we have another line which is parallel to this line, so in this case the slope of this line would be equal to the slope of this line. Hence, if AX plus BY plus C is equal to 0, then AX plus BY plus K is equal to 0 is the equation of this line. Your K is any unknown. Once again, if a line is AX plus BY plus C equal to 0, and we have to find the equation of line, then AX plus BY plus K is equal to 0 is the equation of this line. Your K is an unknown. If we substitute different values of K, we get different lines which are parallel to this original line. Now how to find the equation of a line perpendicular to a given line? If we have been given that the equation of this line is AX plus BY plus C equal to 0, and we have been given another line but it is perpendicular to this very line, so the equation of this line becomes equal to BX minus AY plus K equal to 0. Here, if the slope of this line is equal to M2 and the slope of this line is equal to M1, then M1 into M2 is equal to minus 1, as the lines are perpendicular. So from that we get the equation of this line as BX minus AY plus K equal to 0. Again here K is an unknown. If we substitute different values of K, we get different lines perpendicular to this very line. Now angle between two lines. If I have been given two lines and their equations are a1x plus b1y plus c1 equal to 0, and another line has been given whose equation is a2x plus b2y plus c2 is equal to 0, then the angle between these two lines is, let's say, theta. Then tan theta is equal to modulus of a2b1 minus a1b2 divided by a1a2 plus b1b2. Once again, If two lines have been given and the equations are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, then the tan of the angle between these two lines is given by modulus of a2b1 minus a1b2 divided by a1a2 plus b1b2. Now here we have different cases. If I say that a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then these lines are coincident, that is, it represents the same line. If a1 by a2 is equal to b1 by b2 but it is not equal to c1 by c2, then in this case I can say that the slopes of these two lines are same and hence these two lines are parallel. If a1 by a2 is not equal to b1 by b2, then in this case the lines are intersecting, and if a1 into a2 plus b1 into b2 is equal to 0, then the lines are perpendicular to each other. Once again, if a1 by a2 is equal to b1 by b2 and which is ultimately equal to c1 by c2, then the lines are coincident, that is, they represent the same line. If a1 by a2 is equal to b1 by b2 which is not equal to c1 by c2, then the lines are parallel because the slopes of these two lines are the same. In the third case, if a1 by a2 is not equal to b1 by b2, then the lines are intersecting. They are neither parallel neither coincident, and hence these lines are intersecting. And if a1 into a2 plus b1 into b2 is equal to 0, then the lines are perpendicular. Now students, we are going to study a very important form of line, that is the parametric form. It is also sometimes called as the distance form of a line. Let us say we have this line and it makes an angle of theta with a positive direction of x-axis. It is also given that it passes through a point x1, y1. Now, if I take any point P, x, y, it is a variable point and it lies on this line, and it is at a distance of r from this fixed point through which the line passes. Let us say that PQ is equal to r, that is, the distance between Q and P is equal to r. Now, this distance would be equal to y and this distance would be equal to y1. So, this distance is equal to y minus y1. Similarly, this distance is equal to x2 and this distance is equal to x1. So, this distance would be equal to x minus x1. Now, this line is parallel to this line, so this angle is also equal to theta. Now, we consider this right angle triangle. Now, cos theta would be equal to x minus x1 divided by PQ, or x minus x1 divided by r, because the length of PQ is equal to r. Similarly, sin theta would be equal to y minus y1 divided by PQ, and that is equal to y minus y1 by r. Now, cos theta is equal to x minus x1 divided by r, and sin theta is equal to y minus y1 by r. So what we do is we equate these two expressions, that is, x minus x1 by cos theta is equal to y minus y1 by sin theta, and which is equal to r. Now this is the equation of the required line. That is, if we have been given the slope of this line, that is, the angle theta is been given, and we know a fixed point through which this line passes. So we can write the equation of this line in a parametric form as x minus x1 by cos theta is equal to y minus y1 by sin theta, and which is equal to r. Now the coordinates of any point P on this line would be equal to x is equal to x1 plus r cos theta and y is equal to y1 plus r sin theta. So these are the coordinates of any variable point on this line. Now important point to note is, if the point P lies on the right hand side of point Q,